Okay, this video we're walking through the 3 FRQs that made up your FRQ 1. A reminder with FRQs that your goal really isn't to get 100%. I mean, it is and it isn't, right? It's always great to be able to get 100% of them right, and if you're able to, that's fantastic. But the goal with each FRQ really is to identify what is one point that I can get right next time. Being very purposeful at identifying those and kind of filing them away within our brains. As we walk through these, I'm going to try to identify kind of where in your notes you can find the ideas that we're discussing. Although, as previously stated in the Tabular Data video, the challenging things about, I'd say especially the calculus FRQs, is that very few of them come from one unit or one lesson. It's why it's so hard to do them until you kind of have a full realm of knowledge, because these come from all different units, all different lessons. Which is why I said the goal isn't to get 100% necessarily, it's to identify what's one more point I can get next time to try to get me into my 3, 4, or 5 zone. Okay, so this particular one came off the non-calculator portion of the 2016 exam. Okay, I think I mentioned in the previous video, I'll always notate this so that if you are wanting to look up the answers before I release the answer key, you're more than welcome to do so. But make sure you're using that wisely, right? Copying doesn't do you any good. It doesn't give you a chance to be able to figure out what is it that I'm actually understanding or not. Okay, but so this one came off non-calculator 2016. It said the functions f and g have continuous second derivatives. Okay. The tables above give values of the functions and their derivatives at selected values of x. Okay. A says, let k of x equal f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. Okay, so writing an equation of the line tangent has actually been in our notes quite a few times at this point. It would have first been put into our notes in 2.1. And then again, I think the second time would have been 2.5, where we reviewed what it means to be a normal line or a perpendicular line. And then would have been also in our notes, I know at least during fall final review, if not, I think also at one point in Unit 5. But an equation of the line tangent, the minute you read equation of line tangent, that should trigger y minus y1 equals m times x minus x1. Because then we're going to be identifying those different pieces to write our equation. What is our y1, our slope, our m, and our x1? To the graph of k at x equals 3. Okay, so we've got an x1 here, so let me go ahead and write that in. X minus 3. So the question then becomes, well, what is my y value? What is my slope value? Y's, a reminder, are either given in some way, shape, or form, or you find them by plugging your x into your original equation. That's how we find the y coordinate of like a point of inflection or a relative extrema, that kind of thing. It's how we find our y coordinate for our equation of the line tangent here. Okay, so taking my 3 and plugging it into my original equation to find my y coordinate, k of 3 would be f of g of 3. And so then evaluating that, well, g of 3, I know from my table, is 6. And f of 6, from my table, 6, f of 6 is 4. And so my y1 is 4. Okay? And then slope from day 1, so 2.1 is where we would have first written this in. Slope is derivative of the line tangent, or so slope of the line tangent, I should say, is the derivative. And so in this function, we're taking the derivative of our value here. Well, to take the derivative of this particular function, this comes out of 2.4 in your notes. So I'd say most of this lesson comes from 2.1 and 2.4. 2.4 in your notes, because this here is chain rule. Okay, derivative of my outside would be f prime, leave the guts alone, times the derivative of the guts, which is g prime. You can also find some like this in your fall final review. So we'll call it fall, I'll just say fall final, would be the other place to look for other examples of this idea here. And then plugging in your 3, So k prime of 3 is f prime of g of 3, g prime of 3. G of 3 here, in this particular case, is 6, g prime of 3. And then f prime of 6, so f prime of 6 is 5 times g prime of 3, which is 2, gives me a slope of 10. Which you also could write, technically speaking, as 5 times 2. Because remember, you don't have to simplify anything on an AP free response. Okay, this particular problem was worth 3 points. Okay, so 3 points total. 2 points came from your slope at x equals 3. So it came from this process over here, had 2 points within it. And then the third point came from the equation for the tangent line. Now that your answer, I should say, that third point could still be earned even if you made a mistake in finding your slope, as long as you didn't oversimplify the problem. So we can't just like make up a number, right? So as long as you didn't oversimplify your problem, if you did make an error within this derivative process, it's possible you still earned your equation for the line tangent point, even if you didn't get 10 for your slope. Okay? And as always, if there are questions on anything with grading, if you're looking at yours going, I don't know if I would earn this point or whatever, feel free to contact me, and I'm more than happy to check your work for you if you'd like. Okay? Okay, B, we have let h of x equal g of x over f of x, find h prime of 1. Okay, so this would come originally out of 2.3, but then you also could look at your fall final review. We actually did one almost exactly like this in our fall final review. Okay, so to find h prime, in this particular case, this would be quotient rule. So we would have low, which is my f of x, d high, which is g prime of x, minus high, which is g of x, d low, which is f prime of x, all over low squared. Okay, that process then allows us to now plug in 1. So h prime of 1 equals my f of 1, g prime of 1, minus g of 1, f prime of 1, all over f of 1 squared. Okay, and then pulling out our values, f of 1 in this particular case is negative 6, g prime of 1 is 8, minus g of 1, which is 2, times f prime of 1, which is 3, all over f of 1, which is negative 6 squared. And then I would highly recommend stopping there. Reminder that you don't have to simplify anything, so you can't leave it unevaluated. Unevaluated would be like here, but you can leave it unsimplified. Kind of rule of thumb, if you could plug it into a basic calculator, not a graphing calculator. Remember, graphing calculators are very powerful. But if you could plug it into a basic calculator and generate an answer, you're probably good to leave it there. So if I plugged that into a basic calculator, it wouldn't give me an answer. But if I plugged that in, it would. And so I can leave it here. If you did simplify it all the way, it would give you negative 3/2. But again, I highly recommend not doing that. It's a waste of time. And if you do make an error in that process, you've now lost your answer point. This particular problem was worth 3 points, 2 for your expression for h prime of 1, so that would have required quotient rule. If you just did g prime over f prime, that is, I would say, significantly altering the problem. So using your quotient rule here, you get 2 points. And then 1 point came from your answer, which is being able to pull out the appropriate values and then not simplify, right? If you pulled out the accurate values here, but then simplified wrong, you'd lose that third point, that answer point, because you have an inaccurate answer at that point in time. Okay, so leave it here. Okay? And then again, any questions on grading, feel free to contact me and let me know if you're wondering, like, how many points would I get for this, that kind of thing. Okay? C here, so C comes out of I'd say a mixture of 4.4 and 4.5. And then a little bit, I'd say unit 5 as well, if you wanted to think of it as unit 5. But we are evaluating the integral from 1 to 3 of f double prime of 2x. Okay, so we know that this is going to require us to take an antiderivative and to then apply fundamental theorem of calculus, which is plug in the upper minus plug in the lower. Okay, well, the antiderivative of f double prime is f prime. However, we've got a chain rule component in here. Okay, which remember, there's no product rule, no quotient rule, no chain rule within an integral, so this is what comes out of 4.5. There's actually a u to u substitution within this problem. My u would be 2x, my du then would be 2 dx, which would give me 1/2 du equals dx. And so that 1/2 would need to be part of my problem. And so that's where I said it kind of ties a little bit to Unit 5, because we talked about u to u substitutions again at that point. In Unit 5, throughout Unit 5, we said over and over and over again, if it's not a singular variable within your function, all of those places that you see a single variable is supposed to be, if there's any chain rule implied, like however it is you want to think of it, but if it's not a single variable, if it doesn't have a du of 1, then you have to do a u to u substitution on that element. Okay? And then plugging in our upper, we have f prime of 2 times 3, which is 6, minus plugging in your lower, 1/2 f prime of 2 times 1, which is 2. Oh, I just realized you also could have changed your bounds if you had left this as u. If you left this as u in here, f prime of u, then your bounds would be, let's see, 2 to 6. So that would be the other way to work through this problem. And again, if there's questions on that, contact me. I'm more than happy to work it out for you. Okay, but f prime of 6, pulling that from my table up here, f prime of 6 is 5. So 1/2 times 5 minus 1/2 times f prime of 2. Up here, f prime of 2 is -2. And then leave it. Don't simplify again. Waste of time. What if you make an error? But if you did simplify, you would get 7/2. This one was also worth 3 points, 2 for the antiderivative, the integral piece, and 1 for your answer. Which again, there is partial credit within that, so as long as you didn't oversimplify the problem, you could potentially earn part of those 3 points. And again, if you're ever not sure, take a picture of it, email it to me, or in our Zoom meeting, if you're able to log in at that point, you can ask, or you could just like message me in the comments, whichever one you're most comfortable with. I'm more than happy to check that for you. Okay? Okay. Question 2, we have a particle moves along the x-axis with velocity given by v of t equals 10 sine of 0.4 t squared over t squared minus t plus 3. Okay, so as I read this, particle, so I know I'm looking at velocity here, so looking at the derivative of position, thinking about that, I've got some bounds, 0 to 3.5, so I'm not going to name anything outside of those. The particle is at position -5 at time t equals 0, so I've got a starting position there, 0, -5. And so anytime I see position, I'm already thinking maybe desired position formula. Maybe? Question mark? I don't know. Why else would they give me a position? Possibly. Okay, and so then A, we are looking at find the acceleration of the particle at time t equals 3. So almost all of this problem is going to be from the particle motion packet. So I'm going to put PM for particle motion. Acceleration is the derivative of velocity. Right, we wrote that down on the front page of your particle motion packet. And so therefore, if I have velocity here, I could take its derivative and plug in this case, 3. Now you have an option here. It is a calculator one, so you don't actually have to do this by hand. You could go to your calculator, plug that in, 10 sine of 0.4 t squared over t squared minus t plus 3. And I'm going to go ahead and change my window from 0 to 3.5 just to make sure that I don't get distracted by outside values there. And then you can have your calculator calculate the derivative at t equals 3 if you want. Or if you don't do it in your graph screen, if you do it in your home screen, that's fine too. However it is that you typically find a derivative in your calculator. For me, like I said, I typically do my graph. So I do second calc or F5 or analyze graph or GSolve for depending on what calculator you have. And then your derivative. And then we want the derivative at 3, so I'm going to go ahead and type in 3, and it'll tell me my derivative at 3 is negative 2.118. Okay. It's a negative 2.118. If you do this by hand, you would need to do quotient rule with chain rule and the d high when you're doing that. Honestly, though, it's kind of a waste of time because it is a calculator question, and this one was only worth 1 point. And so you really do kind of want to use your calculator on it. Okay. If there are units, your units would be distance over time squared, so maybe like meters per minute squared or something like that, but we don't have units, so our answer is just negative 2.118. Okay. Okay, B, find the position of the particle at time t equals 3. There we go. That's what I was kind of expecting up here. This is my desired position formula. So again, particle motion, so we'll go ahead and put page 1 for A. The back side of page 1, so we'll call it page 2, is where we wrote the desired position formula in. It is x sub A plus the integral from A to B of your velocity. Right? So x sub A is your given position. In this case, my given position is negative 5. A is my time corresponding to that position, which is 0. B is the time I'm trying to find, which in this case is 3, and then my velocity would go inside of my integral. Okay? And so then going to my calculator, I've already got velocity graph, so I'm just going to use my graph for this one. Second calc, integral, lower limit is 0, upper limit is 3, and then I'm going to make sure I add negative 5 to it. Negative 5 plus, it's almost done. Integral is 3.2397868. Okay, and then you don't actually have to simplify, remember, so I could leave it there if I wanted to. That's accurate to 3 decimal places, so I'm good to go. If you did simplify that, negative 5 plus 3.23978 would be, I believe, negative 1.760, but let me double check that. 97868, whoops. Negative 1.760, yeah. So you could simplify it all the way if you wanted to, but again, you don't have to simplify, so you're good to leave it here. This one was worth 3 points. 1 point came from evaluating the integral from 0 to 3 of velocity. So this ties to a previous, the tabular data video that I made earlier. A reminder that if you're ever sitting there, honest to goodness, stuck about what to do something. Right? Take a derivative, take an integral, do something. See if there's a word that might cue it. And so potentially speaking, if you were in a testing situation and you read this problem and you're like, I don't know how to find position, I don't remember, but maybe you remember position is the integral of velocity. Well, then take the integral of velocity and go to 3, because that's what they're having you do, so 0 to 3. Maybe you're sitting there going, I don't even remember that position is the integral of velocity, but I took a derivative in A, so I'm going to do an integral in B, just because if a derivative gave me acceleration, a derivative wouldn't also give me position. And so maybe that's your thought process. But do something. Don't leave anything blank, because even if you had just taken the integral of velocity, you would have gotten 1 point. 1 point then came from remembering to use your initial position, so starting there at negative 5, so having that be part of your problem. And then the third point came from your answer, which is over here. And so again, it is possible to snag this answer point even if you messed up some in here. It again would depend on how you messed up. So let me know if you're not sure. I'm more than happy to check your work, but it is possible to still snag the answer point as long as you didn't oversimplify the problem. So 3 points possible. Okay? Okay, C, also from our particle motion packet, we would have written these down on, again, page 2, like the desired position formula. It says evaluate 0 to 3.5 of velocity. Okay, so I'm going to go ahead and do my, go to my graph here. We're going to go all the way to 3.5 for this one. So 0 to 3.5. It's working. There we go. Which is about 2.8439445. Okay. And then we're doing 0 to 3.5 of the absolute value of velocity. So rather than type all that in my graph screen, I'll go ahead and do it in my home screen for those who prefer to do it there. So math 9, 0 to 3.5. Absolute values, math over 1 absolute value. We type in our velocity, 10 times sine of 0.4 t squared over t squared minus t plus 3. And it's going to calculate it. You need about 3.737. Okay? So evaluate that and that. Interpret the meaning of each integral in the context of the problem. So this first one, what was it when we were without absolute value bars? 0 to 3.5 of velocity is the displacement of our particle. And then remember with your descriptions, you always want to make sure that units and time intervals are there. So if we did know kind of how much distance was moved here, you'd say the displacement in meters or the displacement in feet or whatever the case may be there of the particle. And then our time is from t equals 0 to t equals 3.5. And again, if we knew time units, so minutes or seconds or something like that, we'd include that in our description. Okay. The other one, what was it when there were absolute value bars? Okay, well that meant it was total distance. It's the total distance traveled. And again, maybe you'd say in miles or in meters or centimeters, whatever the units were if we knew them. Traveled by the particle from t equals 0 to t equals 3.5. And again, minutes or seconds or whatever. This one was worth 3 points. 1 point came from your 2 evaluations, so you did have to have them both right. Again, it was a calculator problem, so it just means being very careful about plugging into your calculator. And then 2 points came from your interpretations of each. So knowing that this one is the displacement from 0 to 3.5 and this one's the total distance from 0 to 3.5. Okay? Last but not least, we have our part D here, which we now know is going to be worth 2 points because we are at so far a total of 7. So 2 points here. Says that a second particle moves along the x-axis with position given by this function. So I'm looking at a position function. At what time t are the 2 particles moving with the same velocity? So what does it mean to be same? It means to be equal. And so I need my first particle's velocity, 10 sine of 0.4 t squared over t squared minus t plus 3 to equal my, my second particle's velocity. And so what do we have here? What is this function. This is position. And so to find its velocity, I would need to take the derivative of that position function. So in this case, my velocity would be 2t minus 1. Okay. And so then where are those equal? Well, it is a graphing calculator one, so you have a couple of options. One, you could graph both of these functions. I already have one of them graphed. And then I could graph the other one. I could look to see where they touch, where they intersect. Okay? Or you could subtract this 2t minus 1 over. So 0.4 t squared over t squared minus t plus 3 minus 2t plus 1. And you could plug that entire function into your calculator. So coming back up here, minus 2t plus 1, and you could graph that and you could see where it equals 0. Where does it touch to the x-axis? You could calculate zeros there. So both of them will work. It's just whichever one you prefer. For me, I'm always a zeros person because I don't like having to adjust my window to find intersections. When you're just looking at functions like this, you don't really know where they're going to intersect. So it could potentially be all the way up at y equals 12 or y equals 35. And I don't want to have to, like, I just find it annoying to have to keep moving my window around. So I like getting it to equal 0 because then all I care about is can I see my x-axis on this time interval here. Because then anywhere where I can see my x-axis between 0 and 3.5, I'll be able to find a 0. So I always do a 0 myself. And so we'd have gotten t equals 1.570 for your answer here. This one was worth 2 points. One came from setting your two velocities equal. Again, referencing the importance of putting down anything you can think of related to the problem. Even if you were sitting there going, I don't really know how to solve part D, but I know what it means to have same velocity. It means they are equal. Well, then write the two velocities equal to each other, because even if you had just done that, you would have still gotten a point. So anything you can think of related to the problem as you're reading through, especially these challenging ones. Most FRQs, I should say a lot of FRQs get more challenging as you work through. So part D will usually be more challenging than part A. So especially as you're getting later on, you're going to hit ones that are harder, that are going to stretch and kind of push you out of potentially your normal comfort zone. But if you could write that down, you would have still gotten 1 point. And maybe you don't get this last point. Again, it's okay to not get 100%. I know that that's weird, and I know I want us to understand how to get all 9 points, but that's again not really the goal. The goal is to identify with each FRQ what's one more point I can get right next time. Okay? Also remember, you have 15 minutes for one FRQ like this. So even with all of my extra talking here, we're still sitting at less than 30 minutes on the 2 FRQs that we've done. I still haven't even hit my time limit for the 2 FRQs we've looked at. Okay, so you've got plenty of time to slow down, to think, to write down anything you can think of related to the problem. Okay? Okay, last but not least, we have a tabular data one. So this one ties to the 4 we already did on Monday, or the ones you should have done on Monday. I made a video walking through all 4 and encouraged you to at some point pause the video and try them on your own, because you're going to continue to see them. Well, here's the first one of continuing to see them. And again, they're going to keep showing up. Okay? So, no calculator 2018, we have the height of a tree at time t is given by a twice differentiable function h. So, I'm looking at height here. So I'm thinking potentially some sort of position. We're looking for like feet or something like that. I always take note of my units. So in this case, I know it's meters for my h, height. Twice differentiable, so I can take 2 derivatives if I want. It's differentiable, it's continuous. So I'm thinking potentially maybe IVT or MVT. The fact that they've told me that. Remember, we wrote down on the tabular data day that those are 2 common ones to reference. IVT helps us to prove that a point exists, and to say that you have to be able to state your continuous and be able to state bookends. MVT states that a derivative exists, a slope exists of some sort, and you have to be able to say that you're continuous and differentiable, and be able to find a point or 2 points that give you that slope, f of b minus f of a over b minus a. So that's kind of what I'm thinking. Where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. Sorry. I obviously restructured this paper for printing purposes, so that should say above. Okay, A, use the data in the table to estimate h prime of 6. Okay, so we did a couple of these on the Monday one, h prime of 6, so we're looking at this point in time right here. H prime is a slope of some sort, and so we're looking at change in y over change in x, so either 6 minus 11 over 5 minus 7, or 11 minus 6 over 7 minus 5, whichever one you prefer, and then leave it alone. You don't have to simplify, right? Leave it there. Okay? If you do simplify, you should get 5 halves. Okay? Then, using correct units, interpret the meaning of h prime of 6 in the context of the problem. Okay, so did a little bit of explaining meanings on the video on Monday, but we're going to continue to see them and continue to walk through them because I know they're a little weird at first. So meanings, as I said on Monday, I tend to recommend just very purposefully with each piece kind of rewrite what that element of your whatever expression is they're asking you to explain. In this case, h prime of 6. What does that element mean for my problem? Okay? And so for my explanation, it would look like something like this. H prime of 6, means, and I'm actually going to say represents the, and then what is h prime? Okay? Well, the most tempting thing to want to say is that it's a slope, which if we were looking at a line would not necessarily be wrong, but I'm not looking at a line here, right? We're explaining this in the context of the problem. We're looking at a tree. Okay, and so we have to figure out, well, how else can I say that word? Okay. Well, we also wrote these down on Monday. Reminder of what an integral is. An integral is something about total or area or accumulating or volume. Okay, a derivative is a rate or a slope or a rise over run. So because we're looking at a tree here, the word that's going to help us the most is this, rate. Okay, so it represents the rate at which, and then what is happening here, this is my tree's height, so the rate at which the tree's height is, and you could say changing if you wanted to. You could say growing in this particular case if you wanted to, because this does simplify to a positive rate, so you could say growing. Careful if this was a negative rate, that if you said that the tree was shrinking, right, like those related rates ideas, you're wanting to make sure you watch negative verbiage. So the rate at which the tree's height is growing, the rate at which the tree's height is changing. Oh, and I'm going to throw in my units here. Height in, because we know units, in meters. In meters is changing at, and then t equals 6 years. Okay. Remember, with explanations, always make sure you use units, so the meters and the years, to describe what you're doing, and include the time elements. In this case, it's t equals 6 years. Okay, this problem was worth 2 points, 1 for the approximation and 1 for the explanation. And you did need to have units. If you didn't have units in there, because they said using correct units, you had to have them in this case. You should always put them in if you know them, but you had to have them in this particular case. Okay? Okay, B, explain why there must be at least one time t between 2 and 10 such that h prime of t equals 2. Okay, so they're asking me to guarantee a slope exists. This tells me I'm thinking MVT. Okay, well, if MVT exists, two things need to be true. One, I have to be continuous and differentiable. They told me that, so I'm good to go. And I have to find 2 points B and A such that their slope gives me, in this case, a slope of 2. And so my recommendation, I said this in the video on Monday, is to always start with the 2 points they give you. So I would be doing my f of b minus f of a over b minus a. Okay, h of 10 is 15 minus h of 2, which is 1.5, over 10 minus 2, which is 8, which unfortunately is not 2. And so this does not end up helping me. Okay? And talked about this on Monday as well, and referenced this also when we learned this, which was in 3.2, if you're wanting to look for other MVT examples. I'd say most frequently, I shouldn't say most frequently, quite frequently, the 2 points given are the 2 points you'll end up using. But in this particular case, this is an example where the 2 points 2 and 10 that they gave me don't actually end up helping me. Plus, I had a little bit of a hint that 2 and 10 wouldn't end up helping because of the lack of equals, and so that makes me start to question it. I still would test it just to be safe, right? Still test it. But it doesn't work, so then we're looking at, well, okay, I need 2 different points then that are between 2 and 10. And so maybe you try 7 and 5 next. H of 7 minus h of 5 over 7 minus 5. Well, h of 7 is 11 minus h of 5, which is 6, over 7 minus 5, which is 2, which is 5 halves, also does not equal 2. Okay, so 7 and 5 don't work. And potentially it might take you a number of different tries until you find one that works, but eventually you will land on h of 5 minus h of 3 over 5 minus 3, which is h of 5 is 6, h of 3 is 2, 5 minus 3 is 2, and 6 minus 2 is 4 over 2, which is 2. And so I've just found 2 points that give me a slope of 2. Okay? And so therefore, why can I say that that exists? Because, and again, there's lots of ways of phrasing this, but I'm going to say because h of t is twice differentiable, and therefore continuous, and because my 2 points here, so h of 5 minus h of 3 over 5 minus 3 equals 2, and then something about there must exist some value. And then you could say all the way 2 to 10 if you wanted to, but we actually know that the value exists between 3 and 5, so you could also restrain your values to 3 to 5 if you wanted to. So there must exist some value on, and then either 3 to 5 or 2 to 10. Yeah, let's go ahead and do 3 to 5. I think that's what they did on their rubric, if I remember correctly. And their example of an answer. Must exist some value on 3 to 5 such that h prime of t equals 2. Okay, this one was worth 2 points. One was for finding the 5 and 3, which give me a slope of 2. So this stuff. And one comes from articulating MVT, which again, there's a variety of ways of doing that. So if you're looking at your way going, I don't know if this works, take a picture, contact me. I'm more than happy to check it for you. Okay, C, use a trapezoidal sum with 4 subintervals indicated by the table above. So 4 subintervals, we're going all the way from 2 to 10. So I'm going the whole distance, 2 to 3, 3 to 5, 5 to 7, 7 to 10. This is a distance of 1, 2, 2, and 3. To approximate the average, so average, we're talking 1 over b minus a times the integral from a to b. So the average, and then height, so h of t of the tree over the time interval 2 to 10, which is why A and B are 2 and 10. Okay? So 1 over B minus A is 1/8, and then we've got our trapezoidal sum here, so 1/2. Trapezoidal, remember, is your change, which is your 1 in that first subinterval, and then not the left, not the right, but both, 1.5 and 2. Second subinterval, 1/2 your change, which is 2, and then not the left, not the right, so not just 2, not just 6, but 2 and 6. Third subinterval, 1/2 your change, which is 2, and then not the left, not the right, but both, 6 and 11. And fourth one, 1/2 your change, which is 3, not the left, not the right, but both 11 and 15. And then don't simplify, leave it alone, okay? You would get 2 points for this problem. 1 was for the trapezoidal sum, and 1 was for your approximation, which would require the 1/8. If you didn't catch that this was average, and so you didn't have this 1/8 out front, you would lose that approximation point. But you could still get your trapezoidal sum if you set that up correctly. Okay? Average, by the way, is 4.4. Trapezoidal sum is 4.6 in your notes. Okay? Okay, D, we have the height of the tree in meters can also be modeled by the function g, given by g of x. Okay, so we've got a height function here, so this is height, where x is the diameter, so x is diameter. I'm going to go ahead and bring those a little bit closer. X is diameter in meters. When the tree is 50 meters tall, so here 50 meters tall, this is my g of x here, equals 50. The diameter of the base of the tree is increasing, so this is a positive idea, a rate. So this is a ddt, and this is the rate of what? What's increasing? It's the diameter of the base of the tree is increasing at a rate, so this is dx dt, positive 0.03. Remember, if they said decreasing, we'd need to make this negative 0.03. According to this model, what is the rate of change? So we're talking a ddt of some sort of the height of the tree. Well, that's my dgt in meters per year. So we already know our units there. At the time when the tree is 50 meters tall. So again, they're telling me g is going to be 50 meters tall. Okay. So what is the rate of change? So what is dg/dt? Well, taking the derivative of our g function there, okay, we have our quotient rule. So low, which is 1 plus x, d high, which is 100, and then I just took the derivative of an x, so dx dt, minus high, which is 100x, d low, derivative of 1 plus x is just 1, and then dx dt, all over low squared, 1 plus x squared. Okay. For the record, you just earned 2 points by being able to take the derivative of this function. There is potentially room for some partial credit. It kind of depends on what happens. So again, take a picture, send it to me if you have a question. 1 second. Felt like I was going to sneeze. Sorry. So take a picture, send it to me. I'm more than happy to check it for you. But 2 points came from that derivative. And then 1 point came from your answer, which is now being able to solve for that dg/dt. And so this last point, in my opinion, is one of the trickiest ones of this problem because my x is my diameter. And so my dg/dt at the point when the tree is 50 meters tall, at height of 50 meters, is, and then the problem is that 50 does not go into my x's spot. My tree is 50 meters tall, That doesn't mean my diameter is 50 meters. My diameter is the x, my g is the 50. So what we would have to do is set my g function equal to my height of 50 and solve for that diameter. So multiplying this 1 plus x over would be here. Distributing the 50 plus 50x. Subtracting the 50x over. And dividing the 50, we get that our x is 1. And then my 100, my dx dt, which was 0.03. And actually, I'm going to rewrite this underneath because I'm going to run out of room. 1 plus 1, 100, dx dt is 0.03. Minus 100, my x is 1. My dx dt is 0.03. All over my x, which is 1. And then definitely don't simplify. There's way too many places in this process where you could make an error. If you do choose to simplify, it does simplify down to 3/4, but again, it's a waste of time. And then meters per year were my units. Okay, and that was your third point, came from that answer. Okay. Okay, so that's FRQ1. Again, if there are questions, feel free to either email me, comment on your assignment if you prefer, or log into a Zoom meeting as soon as those get scheduled, and we can talk about it if that's what you'd prefer. But obviously, if you're wanting me to just kind of answer it one-on-one, I'm more than happy to do that through an email or comment if you prefer.